As you have only MCQ questions for the first term examination, let us do MCQ questions which are given in the NCERT textbook. We have to be thorough with these answers. First question, let R be the relation in the set 1, 2, 3, 4 given by R equal to 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3, 3, 2. Choose the correct answer. In this given relation, we have 1, 1, 2, 2, 3, 3. Therefore, this relation is reflexive. Now we have 1, 2, but 2, 1 is not there. Therefore, it is not symmetric. The relation is not symmetric, so first option is wrong. It says that it is symmetric. C option is also wrong. Here also it says that it is symmetric. D is also wrong because if it is an equivalence relation, it should be symmetric. So the correct option is B. And you can check transitive condition is satisfied. For all A, B, B, C belonging to R, AC is also there. Second question, let R be the relation in the set N given by R equal to set of all A, B such that A equal to B minus 2 and B is greater than 6. So the ordered pair should satisfy both the conditions. B should be greater than 6. Here it is less than 6. So A cannot be the answer. Let us check B option. A is 3, B is 8. 3 equal to 8 minus 2 is wrong. So B option is wrong. C option. A is 6, B is 8. 6 equal to 8 minus 2 is correct. Second condition, B greater than 6. 8 is greater than 6, so C is correct. Whereas for D, 8 is equal to 7 minus 2 is not correct. Therefore, the correct option is C. The third question, let f be from R to R defined as f of x equal to x power 4. Choose the correct answer. Let us check whether it is 1, 1 and onto or not. Since x has an even power, f of 2 is 2 power 4 which is 16 and f of minus 2 is minus 2 whole raised to 4 that is also 16. So 2 and minus 2 have the same image 16. So it is not a 1, 1 function. Now let us check whether it is onto or not. We know that x power 4 is a positive number and f is from R to R. And in the codomain, we have negative numbers also. So for negative values, we don't have pre-images. Therefore, it is not onto. F is neither 1, 1 nor onto. D is the correct option. Question 4. Let f be from R to R defined by f of x is equal to 3x. Choose the correct answer. Let us check whether f is 1, 1 and onto. Let f of x1 be equal to f of x2. That is 3x1 is equal to 3x2. We get x1 equal to x2. And it is true for all real values, which is the domain. Therefore, f is a 1, 1 function. Now let us check whether it is onto or not. Let f of x be equal to y. 3x is y, so x will be y by 3, where y belongs to the codomain R. So for any given real number in the codomain, there is a pre-image x. We have to just divide by 3. Therefore, pre-image is there for every real number in R. Therefore, the function is onto. It is 1, 1 and onto. A is the correct option. Question number 5. Let A be 1, 2, 3. Then number of relations containing 1, 2 and 1, 3 which are reflexive and symmetric but not transitive. Let us write the first relation. The question says 1, 2, 1, 3 should be included. And to make the relation reflexive, we have to add 1, 1, 2, 2, 3, 3. Now it should be symmetric also. Let us write 2, 1 and 3, 1. And it should not be transitive. It is not a transitive relation because 2, 1 and 1, 3 we have. 2, 1, 1, 3. But 2, 3 doesn't belong to this relation. Therefore, it is not transitive. So we wrote one relation which is reflexive and symmetric but not transitive. Let us try one more. The condition is 1, 2 and 1, 3 should be included. To make it reflexive, let us include 1, 1, 2, 2, 3, 3. And it should be symmetric. So 2, 1, 3, 1 should be included. Now we wrote the same thing as R1. So let us try to include one more element. I will include 2, 3. If 2, 3 is included, 3, 2 also should be included to make it symmetric. A has only 3 elements. A cross A has 9 elements and all 9 elements are written here. Therefore, this becomes an equivalence relation. It will be transitive. Okay, but the question says it should not be transitive. Only one relation can be written which is reflexive and symmetric but not transitive. Therefore, option A is the correct option. Question 6. Let A be 1, 2, 3. Then the number of equivalence relations containing 1, 2 is. Let us write the first relation. The question is 1, 2 should be included. And it should be an equivalence relation. Equivalence relation means it should be reflexive, symmetric, and transitive. So 1, 1, 2, 2, 3, 3 should be included to make it reflexive. To make it a symmetric relation, we have to include 2, 1 as 1, 2 is there. Now this is transitive also. Check the possibilities. 1, 2, 2, 1, 1, 1 is there. Then 1, 1, 1, 2, 1, 2 is there. Then 2, 2, 2, 1, 2, 1 is there. Starting with 3, we don't have any element. Therefore, it is a transitive relation. It is reflexive, symmetric, and transitive. This is an equivalence relation. Let us try one more. 1, 2 should be included. And to be reflexive, we have to write 1, 1, 2, 2, 3, 3. And to make it symmetric, we need to include 2, 1. And let us try to include one more element and check. So if I include 1, 3, it has to be symmetric. So 3, 1 also should be included. And to make it transitive, see 2, 1, 1, 3 is there. 2, 3 should be included. If I include 2, 3, 3, 2 should be included. Then only it will be a symmetric relation. A has 3 elements. A cross A has 9 elements and we have written all 9 elements in this R2. Now R2 is also an equivalence relation. So we can write only 2. B is the correct option. We have 2 equivalence relations defined on the given set containing the element 1, 2. Now MCQ questions from inverse trigonometric functions lesson. 7th question. If sine inverse of x is y, then we have to write the condition for y. Set of all y is the range, which is the principal value branch, and set of all x will form the domain. Here the condition is for y, so y should be in the principal value branch of sine inverse. We know that sine inverse principal value branch is closed interval minus pi by 2 to plus pi by 2. So y should be less than or equal to pi by 2, greater than or equal to minus pi by 2, including minus pi by 2 and plus pi by 2. B option is the correct answer. 8th question. Tan inverse of root 3 minus secant inverse of minus 2 is equal to. Root 3 is a positive value, therefore the angle will be in the first quadrant, and we know that the principal value branch of tan inverse is open interval minus pi by 2 to plus pi by 2. So for positive values, the angle will be in the first quadrant, and tan inverse of root 3 is 60 degrees, that is pi by 3 radians, minus for secant inverse, the principal value branch is 0 to pi minus pi by 2. But here the value is negative. Therefore, the angle will be in the second quadrant. Pi minus secant inverse of 2. Secant inverse of 2 is 60 degrees, that is pi by 3 radians. Pi by 3 minus, this is 2 pi by 3. Taking LCM 3, we get pi minus 2 pi, which is minus pi. Minus pi by 3. B option is correct. Question 9. Cos inverse of cos of 7 pi by 6. These type of questions are very important. We can cancel cos inverse and cos only when 7 pi by 6 belongs to the principal value branch of cos inverse. It doesn't belong to the principal value branch of cos inverse, which is 0 to pi. 7 pi by 6 is a third quadrant angle. So let us write this as cos inverse of cos pi plus pi by 6. We know that cos of pi plus theta is, for pi we don't change the ratio, pi plus theta is third quadrant. In the third quadrant, cos is negative. So we get cos inverse of minus cos pi by 6. We can either use cos inverse of minus x formula, which is pi minus cos inverse of x, or we can write it as cos inverse of cos pi by 6 is root 3 by 2. Now cos inverse of a negative value is a second quadrant angle, so pi minus cos inverse of root 3 by 2, and cos inverse of root 3 by 2 is pi by 6. The answer is 5 pi by 6, B option. 10th question, sine of pi by 3 minus sine inverse of minus half. Sine of pi by 3 minus sine inverse of minus half. Principal value branch of sine inverse is minus pi by 2 to plus pi by 2. For negative values, it is negative angle of the fourth quadrant. Therefore, it is minus pi by 6. Sine of, it becomes pi by 3 plus pi by 6, which is pi by 2. And sine 90 is 1. The correct option is D. Question 11. We have to evaluate tan inverse of root 3 minus cot inverse of minus root 3. Principal value branch for tan inverse is open interval minus pi by 2 to plus pi by 2, and principal value branch for cot inverse is open interval 0 to pi. Root 3 is a positive number, so first quadrant angle, it is pi by 3 minus cot inverse of negative value. For negative value, it will be in the second quadrant. So pi minus cot inverse of plus root 3, which is pi by 6. So it is pi by 3 minus 5 pi by 6. Let us take 6 as LCM. 2 pi minus 5 pi. The answer is minus 3 pi over 6, which is minus pi by 2. B is the correct option. Next question, number 12. Sine of tan inverse of x. We can write this as sine of tan inverse of x by 1. We have to simplify this function. We can change tan inverse to sine inverse, so it will be easy for us to cancel sine and sine inverse. So we will use triangle method. Opposite side by adjacent side. We can find the hypotenuse, which is 1 square plus x square. Easily we can change tan inverse to sine inverse. So for sine inverse, we have to use opposite side by hypotenuse, which is x upon root of 1 plus x square. Now sine and sine inverse could be cancelled. Therefore, the answer is x upon 1 plus x square. D option is the correct option. Question 13. Sine inverse of 1 minus x minus 2 sine inverse of x equal to pi by 2. Then x is equal to. We can solve the equation and we can check the answer, or the easier way is the values are given. Let us substitute x equal to half first. In the given equation, sine inverse of 1 minus half is half, minus 2 sine inverse of half. This is equal to minus sine inverse of half. Sine inverse of half is pi by 6, so we get minus pi by 6, but the right hand side is pi by 2. So half is not the answer. Therefore, Option C is the correct answer. X is 0. 0 satisfies the given equation. We get sine inverse of 1, which is pi by 2. Question number 14. Tan inverse of x by y minus tan inverse of x minus y by x plus y is equal to tan inverse of x by y minus tan inverse of, we will divide each term by y here, x by y minus 1 by x by y plus 1. I will use tan inverse of x minus y by 1 plus xy formula, which is tan inverse of x minus tan inverse of y. The second term is in this form. We can write 1 into x by y. So using this formula, the second term becomes minus of tan inverse of x by y minus tan inverse of 1 plus tan inverse of 1 is pi by 4. C is the correct answer. Or you may use tan inverse of x minus tan inverse of y formula also at the beginning.